the Quantum Systems booth here at Intergeo 2020. We would like to welcome you in our booth, and we also welcome our followers on our YouTube live stream. We will go on with our schedule with a next use case presentation presented by my colleagues Pierre Ulfig and Matthias Hecht. It's a German use case, and well, what can I say? It's autumn here now in Germany, and bad weather and stormy season has just started. So what happens quite often? Trees are falling on the railway track of Deutsche Bahn, the German railway organization. And here comes the Trinity and UAVs into play. How can UAVs help to free the railways, or let's say to inspect and monitor the railways? And this is a use case that will be presented by my colleagues. Have fun watching. One thing I have to note that Pierre and Matthias cannot hear you during the presentation, so please hold your questions for after the presentation or write them in the chat, and we will answer them after the presentation in a Q&A session. Have fun watching and listening.
Thank you, Claudia. Yeah, also warm welcome from my side. I'm Pierre Ulfig, the project manager for the FreeRail project. And next to me, Matthias Hecht.
Hello, everybody.
Also involved in this project, responsible for the drone part, and also, yeah, more or less the technical head in this project who coordinates all the technical related questions and issues in this project. So yeah, after my presentation we have also the time for giving you some answers to your questions, and yeah, Matthias will be also then available for your questions, the technical related questions.
I'm pleased to hear your questions.
Thank you, Matthias. So let's start. Claudia perfectly summarized the project. We also have a working title, which you can see here on your slides, hopefully. What is the project about? Yeah, it's the automated recording of vegetation on the railway tracks. Not only, but also after storm damages along the Deutsche Bahn network and railway tracks with autonomously operated drones, in this case the Quantum Systems Trinity. You can see it behind me. This is the version we use in this project. With this project, yeah, we want to contribute, or more or less to help yeah, the people traveling more safely and for sure on time from A to B. This is our vision. Yeah, what we are do in the next few minutes is to give you an overview, also little insights about the problems that the Deutsche Bahn Fahrwegdienste has to face, yeah, to look at our objectives in this project, and for sure how we execute this, how we solve this problem, and yeah, some project status, where we stand, and what we are planning for the future. Short overview, as I said. The starting point of this joint project FreeRail, yeah, deals, as I said, with the digital solution for a growing problem, yeah, in the maintenance of the infrastructure of the Deutsche Bahn. And yeah, the project started in September last year, so 1 year is over, and it will last till end of February 2022. So 2.5 years is the time we have, yeah, time to evaluate this demonstrator. What else to say? The project consortium consists of several partners. I will come to that a little bit later. This is a funded project by the Federal Ministry of Transport and Digital Infrastructure. It's a so-called mFUND project. Yeah, and as I said, the consortium consists of a lot of experts from Geokonzept, Deutsche Bahn Fahrwegdienste, Technische Hochschule Ingolstadt, so the Technical University of Ingolstadt, and the city of Ingolstadt, Stadt Ingolstadt. The question is, who does what, or mainly what, despite the fact that we have a lot of different working packages on track in this project. The main focus of each partners is a little bit different. So let's start with GeoConcept. GeoConcept is responsible for the automated image processing and also the analysis of the evaluated and collected data, and especially with artificial intelligence. The Deutsche Bahn Fahrwegdienste also develop in this project user processes and action plans, also for the use of the daily business, and also to answer the question how smoothly can these findings in the project be implemented in the daily business of the Deutsche Bahn Fahrwegdienste. The THI solved all the problems around about the communication and the data connections, and was mainly involved in the 5G testing over the last few months and weeks. We are also happy to have the Stadt Ingolstadt, the city of Ingolstadt, in this project. Why? Not only because of the fact that the Stadt Ingolstadt accompanies with the survey, the acceptance studies, but also the city of Ingolstadt is a smart city, which means in that specific case that this is a partner city of the European Urban Air Mobility Initiative, and so the advantage for us in this project is that we have access to a great network, and hopefully also to a test field which will be created or offered to us, especially for BVLOS flights in this case. So that's why we're very happy to have also the Stadt Ingolstadt here on board. So these are some facts regarding the project, some additional facts you can see here. It's a huge project. We have 11 main working packages, 68 sub-working packages, and all in all 279 cumulative months, and it's quite a lot. And the project location will be in Ingolstadt or near Ingolstadt, or here at our headquarters, Gilching near Munich. This is a slide to give you an idea how great the expression even at the beginning of this project was, and the interest and the positive feedback during the beginning. And here you see on the left side our CEO Florian Seibel and our Federal Minister of Transport and Digital Infrastructure, Mr. Andreas Scheuer, together with the Trinity and the robot arm. But we will show you that a little bit later. But let's step into and giving you a better idea what is the challenge of the Deutsche Bahn Fahrwegdienste and which constraints he has to solve. So the railway network, and don't forget that we are talking about 34,000 kilometers of nationwide railway network. That's enormously much. So and additionally to that, the fact that at least once a year the inspection on foot or per helicopter with documentation and evaluation has to be done for the whole vegetation, and to find out what is the vegetation condition over these 34,000 kilometer nationwide railway network. This is, as you can imagine, time consuming and also a challenging task due to the fact that this has to be mostly done by an ongoing rail operations. And another fact is that due to the climate change, an increasingly working package are waiting for the employees of the Deutsche Bahn Fahrwegdienste, which makes it not easier for them to solve these problems. So this is the challenge that they have to face, and even though that this is a German picture with German description, it shows you perfectly the safety relevant areas. They have to take care of the distance, of the heights of the vegetation in different safety areas, and with the help of the Trinity, as well as a special payload. No, it's not a special payload. It's a normal RGB camera, the Sony UMC. You can create a lot of different models, like digital surface model, or like digital terrain models. And with the help of these models, you can easily analyze and evaluate the height and the distance. And this is what you can see here on the right hand side in these pictures. And this will help to analyze the safety relevant areas, and to get a better idea in which certain areas a problem exists, or the distance is too short, where they have to react. This is all about that. So our project objective is to develop, on the one hand, a scientific and technical basis for future fully automated drone-based systems, for the digitalized vegetation control, and on the other hand, to create a demonstrator, to develop a demonstrator during the testing phase, and this is what we are trying to do in this project, and we are facing also the problem that all these different subsystems, we will take a closer look on that a little bit later, should be fully automized, and the whole operational process should be a high level of automatization. So, but what does it mean in detail? You can see it here a little bit in short, but we will step in each process a little bit deeper. And with this slide, I want to illustrate the complete and also complex operating process, starting from the drone to collecting the data, to submit this to the Deutsche Bahn Fahrwegdienste, and putting their personnel on site. But let's start with the mobile drone port, which is located near the railway line. And what you can see here is the trailer. The drone port consists of several high-tech things, and this is something that is very, very important to know, that the drone port has a lot of several functions, not only to housing the drone and protecting them for weather conditions, for the different weather conditions, but also acts as a relay station for the transmission, and also for charging the drone, and for the self-sufficient charging of the batteries. And the cool thing is the following, and we will see it a little bit better in the upcoming video. But let me show you here in the slide. We have the camera, which is integrated here in this robot arm, and this robot arm follows exactly the movement of the drone. And the robot arm is equipped with a gripper, and the gripper arm, you can see it here. It's a 3-point gripper, and to get a better idea how it looks and how it reacts, we have the following video. This is filmed indoor, so you can see how smoothly react the robot arm and try to catch the Trinity moves. And you can see that our testing outside. So the arms follows the Trinity, and then has the chance to grip and to catch the Trinity and put them safely into the drone port. So after that, the Trinity will take off. And for those of you who never saw the Trinity flying, or familiar with the technology behind the Trinity, let's take a closer look to this slide. So the Trinity is a special drone. We call it vertical takeoff and landing fixed wing UAV. What does it mean? The Trinity combines the advantages of two systems. First of all, it can vertically start and land like a helicopter, and after the transition phase, it goes in the horizontal efficient flight modus, and uses the efficiency like an airplane. And this is an important thing, because exactly with these technology, with the help of the Trinity, we can fly 50, 60, 70 kilometers, which is necessary in this project, very, very easily. So to cover these 50 kilometers, which is stated in this project, can be easily done with the help of the Trinity F90 Plus, and more it can fly a longer distance rather than a copter. The Trinity was especially designed for covering large areas, for large distance. So this is the perfect drone for us in this project. And also giving you here a chance to get a better idea how this works, the vertical takeoff, landing after transition phase, go in the horizontal flight. Here a little video. Here we can see the takeoff, all the motors. Put the Trinity up, and now we have a slow-mo, and then the motors to two forwards. Yeah, you can see it here on the side. Yeah, the transition phase is now performed, and then it goes in the horizontal flight with the help of the rear motor, and goes in the very efficient flight modus. Here's flying. We will also see the landing, and yeah, this is cool to see that it's very easy to disassemble, to pack it in the box, and yeah, in a few minutes here we are. So this is the Trinity. Feel free to contact our sales team for further information, and that's the Trinity. So let's go on in the process. The Trinity took off and performs the automated mission execution, so the BV lost flight. As I said, 50 kilometers roundabout. This is what we stated in the project, and the mission will perform takeoff. We have then here the performance plan mission, which were planned via our mission planning software Cubase. Collecting the data, the terrain model, which I showed you before, and the payload compartment with the Sony UMC, the RGB camera. Then the Trinity will come back. The recorded data were then transmitted to the server, where the image analyzer starts. What does it mean? The analyzer of the data. It is, on the one hand, the automatic generation of auto photos, but also different classification and assignment of structures, track possible detection of vegetation areas, obstacle detection, pattern recognition, and some other analyzing processes. And these analyses were done by artificial intelligence, most of them, and that is a huge advantage, not to analyze it manually, but with the help of artificial intelligence. And that makes it easier, also to give in that way a quicker response to the Deutsche Bahn. Because what we're trying to do next is to give, we call it a digital action sheet with recommendation for actions. Yeah? As we saw it in the picture, where are the crucial areas, the crucial locations, and these were created, these digital action sheet, which then can be used for the on-site personnel of the Deutsche Bahn Fahrwegdienste. yeah, as I said, we also have in this project, to sum it up, a survey, and we will also put in the public mCloud some data for that. As I said at the beginning, here a deeper insight in the project status, where we are standing. As I said, we started the project in September 2019, so 1 year is over, and yeah, till the end of this year we try to finish the development of the different subsystems, the drone port, the robot arm, the data, artificial intelligence, the data processing, the analysis of these collected data. And then we have 2 months to integrate the whole systems and bring it together, the whole subsystems, and bring it together. And then the very interesting part, and I'm very happy, I'm excited to start the testing phase, which starts in March 2021, and we have 12 months time to test the whole this system, beginning from line of sight flights to BVLOS flights, and to increase the whole automatization process. Let me also add some few challenges we had till now. First of all, the level of automatization is one thing. So to reach a high level of automatization is our goal, is our aim for the entire process. Performing all these steps, starting the drone manually, analyzing the data, that's feasible, and that's easy. But the challenge, comes up when you try to execute the entire process in an automated way. Also, the legal framework, as you may know, flying beyond vision line of sight is a challenge. There exist some legal constraints, and it's not too easy to fly each testing day beyond vision line of sight. This is another challenge we have to face in this project, besides some other technical things. But thirdly, reliable communication. As I said at the beginning, we had 5G testings, successfully 5G testings. So to get a reliable communication over a distance of approximately 50-60 kilometers is also a challenge, and we have to solve that. So that's it from my side, some insights in the project starters, and Matthias and I are very happy to answer your questions.
So, Pierre, Matthias, first of all, thank you very much for the presentation and for introducing the project FreeRail, which I personally like a lot, because I travel with the train a lot, so I think it's in the interest of everyone that rail tracks are free. We have a few questions from the audience. One question is, why is a drone port necessary at all? Why all that effort?
Yeah, I think it's a very technical question, so I will take it. Why is it necessary? So the Trinity, as you see it in the background, has a repetition accuracy of around ±2 meters. So if you have the mission with the Trinity and you fly back to your landing point, you have an accuracy of 2 meters in the autoland mode. And that means that you need to have something adaptive which is able to adapt with the gripper and the end effector to the drone. And in order to do that, you need the robotic arm or something else. We decided to have this robotic arm and to have different kinds of joints, so then to have different kinds of degrees of freedom to grip the drone finally.
Next to that question, Matthias, what is the accuracy of the robotic arm then?
The accuracy of the robotic arm is around ±1.3 centimeters, so 13 millimeters. That means that you have a circle of around 26 millimeters, where the undercarriage of the drone can land, and we have to take care that this happens in this way. So the robotic arm has to be able, with the help of the camera and the visual system, to grip the drone in between this tolerance.
Matthias, is something similar to this solution already on the market?
Yeah, internationally there are some projects available, but none of these projects have the combination which we, Quantum Systems, have, that we have an end effector, a gripper, an automatic gripper, a robotic arm, combined with a visual system, and nevertheless also the Trinity, which its accuracy and mission mode ability is the specialty, or is so special in this combination.
So this is another world's first from Quantum Systems.
Yes.
Perfect. That's amazing. One other question. When will the first outside tests with a fixed installed drone port start?
Yeah, good question. As I said, we start our testing phase in March next year. And yeah, hopefully with the whole systems, so the drone port, include the drone. So yeah, hopefully with the beginning of next year, yeah, March, April next year. Yeah.
As you already saw in the videos, some preliminary tests already started.
Mm-hmm.
You saw the robot arm moving, robot arm was tracking, landing tests are conducted right now. And I think we are good in time.
Yeah.
Time schedule is fulfilled right now.
Yeah.
Very good.
We are on track, yes.
I have one last question for you. I learned that the German railway track route comprises some 34,000 kilometers. Can you disclose how many Trinities Deutsche Bahn plans to buy for this project and to inspect its route network?
Yeah, good questions. We don't know. As you pointed out, this is a huge challenge to cover 34,000 kilometers of railway network. Yeah, this questions we have to hand over to the Deutsche Bahn to get a real and honest answer. We never know. But what I can say, when this project becomes a serial product, yeah, which is our goal, which is our aim, then we think this has a huge impact on the daily business and the daily work of the Deutsche Bahn Fahrwegdienste. So that means for us that there's a huge need, a large need for these systems. So yeah.
Okay. Well, thank you very much for introducing FreeRail to us and to our audience here on our virtual booth and also on YouTube live channel. We will stay here online in our virtual booth, and also Matthias and Pierre, they will be available in the background for your questions. So please reach out to us if you want to learn more about Project FreeRail. If you want to learn more about our Trinity UAV and also Q-based software, then please come back into our room at 3:15. We will be back here with a flight demo of Trinity and also with a live presentation of the product here on our channel. Thanks for watching. See you later.
Thank you. Bye-bye.
Bye-bye. Thank you.